Hello friends, in this video I'm going to answer to all the questions of system of particles physics chapter class 11 okay, which were asked in AHS first year final examination, AHS first year final examination under Assam Higher Secondary Education Council from 2023 to 2025. Okay, so before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. And if you want to follow me on Insta, this is my Insta ID OJHALAKHYAJIT 123. That's my Insta ID. You can follow me on Insta if you want. Okay, so now let's start. So here is the first question: what is the analog of mass in rotational motion? So we know that the physical significance of moment of inertia, here the answer is moment of inertia. Why? Let me explain. So if you know the physical significance of moment of inertia, let me write mi instead of writing this. That is moment of inertia in rotational motion plays the same role as mass does in translational motion. So that is the physical significance of moment of inertia, right? It plays the role of mass. Okay, so the role played by the mass in translational motion, that same role is played by the moment of inertia in rotational motion. So that's why correct answer is moment of inertia. So now let me take the next question. Define moment of inertia and radius of gyration. What is the physical significance of moment of inertia? So I have already told you the physical significance of moment of inertia. Okay, though I will write again. This question was asked in 2025. Okay, the last question was also asked in AHS first year examination 2025 under Assam Higher Secondary Education Council, right? So this was also asked in 2025. Okay, so now let me answer this question. Now you see, suppose we have an axis here and we have a rigid body, and this body is rotating about this axis, and this body may consist large number of particles. Okay, suppose we have a particle, its mass is mi. Okay, it is ith particle. Ith particle means either first, second or third, whatever be the value. If the value of I is 5, then it is fifth particle, you can consider that way. And the perpendicular distance from this distance from this axis of rotation is suppose ri to this particle. Then moment of inertia of this particular particle will be given by the product of mass and the square of the perpendicular distance from the axis of rotation, right? Similarly, if you want to find the moment of inertia of this whole body, then you have to add the moment of inertia of all the particles. Mass, suppose this is the first particle and its radius, distance from the axis of rotation is r1. Similarly, this is second body, suppose m2 mass, and its distance from the axis of rotation is r2. So if you add all those, m1 r1 square plus m2 r2 square plus dot so on, and if you consider this is the product of the mass and square of the perpendicular distance from the axis of rotation of ith particle, then you can write this summation in this way: summation mi ri square. Okay, so what does it mean, summation? That means sum of all the values that obtained by putting I is equal to 1 to putting I equal to n. That means from 1 to n, that means if there are n number of particles, so you will get this sum of this series. Okay, if there are n number of particles, so last term will be mn rn square, right? So you can say that moment of inertia is the sum of the product of masses and the square of the perpendicular distances of these particles from the axis of rotation. So hope you have understood this. So now let me write the definition. What will be the definition? So moment of inertia of rotational, moment of inertia or rotational inertia. So that means we can say moment of inertia is also known as rotational inertia of a body about a given axis, of a body about a given axis of rotation is defined as the sum of the product of masses of the particles of the body and the square of their distances from the axis of rotation, right? So mathematically we can write I is equal to summation from R is equal to, sorry, not from R, that's supposed to be from I is equal to 1 to n mi ri square. Okay, so where mi is the mass of ith particle. So ith particle means it may be first particle, second particle, is just a general term to represent a particular particle of first, second or third. Okay, and ith particle at a distance r1 from the axis of rotation, right? So this is moment of inertia. Now let me write the definition of radius of gyration. Let me write the definition of radius of gyration. Pause the video and note this definition, because I'm going to clean this page to write the so let me clean this page. So now I'm going to write the radius of gyration, definition of radius of gyration. So here you see this is the body. So radius of gyration. So now you see in this body there must be a point, such a point, particular point, to which if the perpendicular distance from the axis of rotation is k, and if the mass of this whole body is capital M, then if you multiply this mass of the whole body with the square of this distance, then you get the moment of inertia, which is equal to summation mi ri square. Okay, then this particular distance k square, that means the distance is actually k, here we are taking the square of the distance, so then this particular distance k is said to be radius of gyration. Okay, so let me tell you again. So here you see this is a rigid body, it is rotating about an axis. This is the axis of rotation, suppose it consisting large number of particles. Okay, so now you see in this body there must be a certain point, okay, somewhere. Suppose that point is here. It must be there must be just a point, so that the perpendicular distance from the axis of rotation to this point, let it be k. Okay, if it is k, then if you multiply the whole mass of this whole body with this square of this distance, it gives the moment of inertia, that is summation mi ri square, which is nothing but I. Okay, then this distance k is said to be radius of gyration. Okay, So now let me write the definition. So first let me clean these things. Okay, now you see, okay, the distance of a point, the distance of a point in a body from the axis of rotation, at which if whole mass of the body, whole of the mass of the body were supposed to be concentrated, its moment of inertia, about the axis of rotation will be the same as that determined by the actual distribution of mass of the body is called radius of gyration, right? Is called radius of gyration. Okay, so hope you have understood this. And as I have already told you the physical significance of moment of inertia in the last question, here you see, so this is the physical significance of moment of inertia, right? The moment of inertia in rotational motion plays the role as mass does in translational motion. Okay, so write that statement. Okay, that is the physical significance of moment of inertia. So hope you have understood this. So now let me take the next question. So that the rate of change of angular momentum of a particle is equal to the torque acting on it. This was also asked in 2025 HS first year final examination under Assam Higher Secondary Education Council. Okay, so now you see, suppose we have a point, it is moving with a certain velocity, so that its linear momentum is p, and let me consider here a point O, and the position vector is suppose r. Okay, then the angular momentum, magnitude of the angular momentum about this O will be given by the perpendicular distance to this line of motion, and the product of this perpendicular distance and the linear momentum, magnitude of the linear momentum, that will give you the angular momentum, right? Hope you have understood this. Suppose, let me write here, let us consider a particle. Let a particle be moving with linear momentum momentum P, and if R be the position vector of it relative to O, then the angular momentum L about O is given by L is equal to R cross P. This is the relation between angular momentum and linear momentum. So now here we need to prove that rate of change of angular momentum is equal to the torque, that means tau, acting on this particle. Okay, we need to prove torque acting on this particle, right? Now you see torque is equal to R cross F. Okay, right, R cross F. Okay, so now first let me differentiate this with respect to T, both side. Okay, differentiating both side with respect to time t. In exam, write completely with respect to, okay, don't write WRT only, though I am writing here. Okay, so if you differentiate with respect to t, this both sides of this equation, then what you're gonna have, let me differentiate both sides with respect to t. Okay, so now let me take a new slide. Okay, so here is a new slide, and let me paste the last step. This is the last step, and here we're gonna apply this ddx of u into v product rule. So according to this, du by dx into v plus u into dv dx. Okay, and in case of now if there is scalar product, you can change the order, but here in case of cross product, you can't change that those order. Okay, so now you see dr by dt cross p. So here you see this term you can write v into du by dx, but here don't write that way. Okay, so keep the order same as here. Okay, so don't write the p first. If you write the p first, then you have to put a negative sign. Okay, this is cross product, because in case of cross product, you know, if a cross b is not equal to b cross a in case of cross product, we know that. So you can write equal if you put here minus, right? So hope you have understood this. So here you see, if we consider this one as u, this one as v, and now apply this rule. So derivative of first function, so derivative of r, second function, that is p here. Okay, then first function, that is r, plus first function, that is r here, cross, as we have cross product, then derivative of second function, in this case p. Okay, derivative of the second function in case of p, which is momentum, right? Hope you have understood this. Okay, now you see, if m is the mass of the body, and v is its velocity, then the momentum p must be equal to m into v, right? So then therefore the above equation, that is time derivative of angular momentum, time derivative of this angular momentum can be written this way, is equal to, so we can replace this p by m into v, right, dr by dt. And one more thing, this velocity is given by dr by dt, so we can replace this by v. Okay, so the above relation becomes v cross and p replaced by m into v, right, then plus r cross, and according to Newton's second law, this rate of change of momentum is nothing but force. Okay, since according to Newton's second law, F is equal to dp by dt, right? Hope you have understood this. Now you see, we know A cross A vector, that means A vector into A vector, magnitude of A into magnitude of A, then sine theta. And you see, when you find a cross product with the same vector itself, then the angle must be 0 degree. This is A vector, and A cross A means, so A cross A, that means cross product of vector with itself. So in that case angle will be 0, right? And sine 0 is 0. So here m is scalar, we know that mass is scalar, and this term can be written as m into v cross v. So v cross v, same vector, so it will be 0, right? So that's why we can write that time derivative of angular momentum is equal to 0 plus r cross f. Here you may write, since v cross v is equal to 0, right? And we know that r cross f is equal to torque tau, where torque is equal to r cross f, which is the torque acting on the body or on the particle, right? And this is what we needed to prove. So hope you have understood this. Now let me take the next question. Next question is, find the torque of a force. Here the force is given. This is the force, that is 7I cap plus 3J cap minus 5K cap. Okay. About the origin, the force acts on a particle whose position vector is this, whose position vector is given by I cap minus J cap plus K cap. This question was asked in 2024 AHS first year examination, okay, under Assam Higher Secondary Education Council. Okay, so torque acting on the particle, answer to this question, right, acting on the particle is torque is equal to R cross F. Okay, R cross F. Then how to find a cross product? So I cap, J cap, K cap. First, here we have R cross F. First write the coefficient of R. So here we have nothing, means 1 before I cap. So let me write I minus 1, here minus 1, then plus 1, Okay, then take the coefficients of this vector f vector, that is 7, 3 and minus 5. Then how to find this? First let me write these coefficients here as well. So give me a second. So here you see, do one thing. In order to find a coefficient cross product of this r cross f, so here you see I have written the coefficients coefficients of I here and at the end as well. Okay, so now you see how to find that cross product. So here you see, first right here I cap, then for I cap ignore this column of I cap, then go in this direction, minus 1 into minus 5, so that is equal to plus 5, right? Minus, then you need to do minus, then multiply these two, 3 into 1, that's going to be 3. So here you see, here we have put nothing, means there is positive, then next time put negative. Okay, next time put negative, then j cap. You can do it by putting positive also, but that will be different case. No, actually you can do both ways. I will explain how. Now you see I cross j is equal to k cap. Okay, and j cross k is equal to I cap, then k cross I is j cap. Now let me explain. So now first let me clean these things. Okay, now you see, so first we have got it for I cap. Now for j cap we have to ignore this column. Okay, as you know, when we have calculated this for I cap, we had ignored the coefficients of I cap. Now ignore the coefficients of j cap, then go from this side. Now you see here you see, if you don't write this column again, I cap column, right? If you don't write this column, now if you want to calculate this, just give me a second. Now if you want to find j cap, and then you need to calculate from this side to, you should multiply this way in this direction, 1 into minus 5. Now if you do this way, I cross j cap, so I cross j cap, so we know k cross I is j. So if you take I cross j, then that I cross k, then it will be minus j if you change the order, right? That's why we are putting here minus sign. Okay, now you see, if you put this column here, and now if you do the calculation, just give me a second. So now if you do the calculation from this side, 1 into 7, then you have to put here positive, because now it is k cross I is plus j, and j cross I cross k is minus j. Okay, so hope you have understood this. Now 1 cross 7, that's going to be 7, minus 5 into 1, that's going to be minus 5, and here we have already 1 minus, so it's going to be plus, so plus 5, right? Then plus k cap, so we have taken this for I cap, right? Then we have taken this for j cap, then for k cap we have to take in these two columns, okay, I and j. Then 3 into 1, that's going to be 3, let me write here, 3, then 7 into minus 1, so minus 7 into minus 1, that's going to be minus 7. Here we have already minus, so that's going to be plus 7, right? Plus 7. Okay, that's what we have got. So hope you know this, how to find a cross product. So then here we're gonna have 2 I cap plus 12 j cap plus 10 k cap. So it is torque, so it must be, its unit must be Newton meter. Okay, so force is Newton, this R is meter, right? Newton meter. So this is the torque in vector form. If you want to find the magnitude, then you would have to find the magnitude of this, taking square root of 2 square plus 12 square plus 10 square. That's you have to do. Okay, so here we are not asked to find the magnitude, so we can keep it this way. Okay, so hope you have understood this. So now let me take this next question. H, write the expression for the moment of inertia of a sphere about an axis passing through its center. Also find its radius of gyration. So let me write that. First pause this video and note all these things, and let me clean this now. Okay, to write the next question, answer to the next question, let me clean the page. So you see, so suppose this is a sphere, and about any axis passing through its center, its moment of inertia is given by 2 mr square by 5. Okay, if capital M is the mass of the sphere. Okay, if capital M is the mass of the sphere of radius capital R, of radius capital R, then its moment of inertia is I is equal to 2 by 5 mr square. Okay, so this is the moment of inertia of a sphere. Now we need to find the radius of gyration. Okay, now you see, if, let me write here, if k is the radius of gyration, then according to the definition of radius of gyration, if the mass of this sphere is capital M, then moment of inertia can be obtained by multiplying this mass of this whole sphere with the square of the radius of gyration, right? Now from these two equations, what we can write, that m k square is equal to 2 by 5 m r square. So here you see m cancels, so then k will be square root of 2 by 5 r square, right? 2 by 5 r square. Okay, and you can take the square root of r square, which gives r. So we're gonna have 2 by 5. If you write r, then write it out, don't write it, if you write r, then don't write r under square root. Okay, it will be taken outside the square root, and if you write under square root, then you must write r square, right? So hope you have understood. So this is the radius of gyration, root 2 by 5 into r, right? So hope you have understood this. So now let me take the next question. So write the equations of rotational motion against each equation. Here you see we had got these three equations. What are this was asked in 2024. Okay, so what are the three equations of motion we had got? V is equal to u plus at, and v square is equal to u square plus 2as. Okay, and s is equal to u t plus half at t square. So these equations were for translational motion. Right? So in case of rotational motion, their corresponding equations are omega is equal to omega naught plus alpha is the angular velocity, angular acceleration, into t. Then next will be omega square is equal to omega naught square plus 2 alpha theta is the angular displacement. And next equation will be S, instead of S we're going to write angular displacement theta. U means omega naught here into T plus half. Instead of A we're going to write angular acceleration alpha then T square. So these are the three equations, right? So hope you have understood this. Now let me take the next question. So define angular momentum so that the time rate of change of angular momentum of the particle is equal to the torque acting on it. We have already proved this one. This one was asked in 2024 and 2025 as well. I have already shown how to prove this. dl by dt is equal to torque, right? I'm not going to repeat this again. In the same video I have already explained earlier, right? So now let me write the definition of angular momentum. Actually I have given this definition as well. Let me show you. So when you are asked to write the definition of angular momentum, then write this much. Okay, that's it. That is the definition of angular momentum. Let me copy this and let me paste that one here. So here is the definition of angular momentum. Okay, so this is the same question. It was repeated. Okay, so this was asked in 2024 and 2025 as well. Here it was asked in 2025, repeating the same question. Okay, so hope you have understood this. Now let me take this question. Define a rigid body and center of mass of the rigid body. So first let me define the rigid body. So this was asked in 2023, right? AHS first year examination under Assam Higher Secondary Council. So let me write what is rigid body. So a rigid body is that in which the distance between any two, let me write the word, I forgot to write this word, between any two constituent particles remains fixed. That means suppose this is a rigid body, so it must be consist of large number of particles. If you consider any one pair of two particles, then distance between these two particles remains fixed. Though if you apply external force from outside, okay, it remains fixed. Okay, on application of force, if they don't come closer, then this body will be called rigid body, right? Hope you have understood this. Okay, so this is the definition of rigid body. Pause the video and note it. Now let me write what is center of mass of a rigid body. Okay, let me write the center of mass here. Center of mass of a rigid body. Okay, so we need to write the definition. Okay, so now you see center of mass of a rigid body is a point where whole mass of the whole of the mass of the body were supposed to be concentrated. Let me write it properly. At this point, concentrated, and this point like mass, this point like mass has the same type of translational motion as the whole body, if some external force acts on this point, okay, as on the body. Okay, so what does it mean? Rigid body is a center of mass of a rigid body is a point such that, suppose this is a rigid body, let me write here, suppose this is a rigid body, let me erase this first. Okay, just give me 1 second. If this is a rigid body, okay, so center of mass is such a point, center of mass of this rigid body is such a point. So now you see, if you apply a force, suppose net external force is acting on this body in this direction, in that case the type of translational motion, okay, that it will undergo, okay, right, and that same net external force, if it is applied on this point in the same direction, then the translational motion will remain same. Okay, so hope you have understood this. That point is center of mass. Okay, so pause the video and note the definition. Let me clean this first. Okay, so now let me answer this question, this part. A body is on y-axis at a distance r from the origin. If a force acts on the body along the direction making an angle theta with the x-axis, then write the magnitude of the moment of force acting on the body. Moment of force means torque, and its dimensional formula. Okay, just pause the video and note the answers first. Now I'm going to clean this. Okay, so here you see what is the question here. Let me clean all these things first to answer this. So in this question it is given that, okay, a body is on y-axis. So this is on y-axis, this is a body on y-axis, and at a distance r from the origin, this is origin O. If a force acts on the body along the direction making theta with the axis, so, and this is along y-axis, right? So let me draw it properly. So here is the y-axis, and this is the body, suppose this is the body, okay, and this is the origin here, you see, this is the origin, and this body is at a distance r from the origin, and a force is acting in this direction that makes angle theta with the y-axis. Okay, so now you see, when you say the direction with the axis, you cannot take this angle. Okay, so that will be angle made by the force, direction of the force and direction of this axis. Okay, so hope you have understood this. So then what will be the moment of force? Okay, so here you see, here given, if the object on y-axis at a distance at a distance r from the origin O, r from the origin O, and if you see, if, let me write in, and theta is the angle between f and y-axis, force F, angle between force F is force here, okay, force F and the y-axis, then perpendicular distance, from the origin, here you see. So if r is the distance from the origin to this object, here you see, this distance is r. Now to find the moment of force, we have to take the perpendicular distance to this line of action. Here the direction in which this force is acting, that is the line of action, and we need to take the perpendicular distance from the origin to this line of action. Okay, now you see, if this angle is theta, then this angle must be also theta. Okay, if this is theta, then from this triangle you can say this is perpendicular, this is base, and this is hypotenuse. We know that sine theta is equal to perpendicular by hypotenuse, and in this case perpendicular is unknown, so perpendicular will be equal to hypotenuse into sine theta, and hypotenuse in this case is r and sine theta. So that's why this perpendicular length, this perpendicular distance is, therefore we can say this perpendicular distance is r sine theta. Okay, then the moment of force, force on the body about O is torque tau. Here if we write in vector form, then we can if we write in scalar form, then we will get this torque is equal to perpendicular distance from O to the line of F into the magnitude of the force F. Okay, so that's why so torque tau will be r sine theta into F. Okay, this is scalar form. Okay, so this is the magnitude of the moment of force. Now what will be in vector form? Let me take a new slide. Okay, so here you see, so what we have got, the last step, the moment of force, magnitude of the moment of force, we have got that r sine theta into F. So let me draw the diagram again. This was the y-axis and this was the object which is at a distance r from the origin O, and this is the direction of force, therefore the line of action is this. So this is the line of action, and here is the perpendicular distance, and this is r sine theta, and this is the direction of force, this is theta, so this must be also theta. Okay, so this is what we have got, which can be written as r f sine theta. So therefore in vector form this will be r cross f. We know cross product of these two vectors is nothing but its magnitude is given by r f sine theta, right? Okay, if you remove this mod sign, there must be an n cap. Okay, so if you write vector here, there's supposed to be an n cap, so which is n cap is perpendicular to both R and F, right? So we don't need to write all these things. Okay, so hope you have understood. Just write this expression only. Okay, this is the required expression. Then what we need, let me go back to the question again. So then also we need to find the dimensional formula. Okay, so here you see dimensional formula. So here we have, this is distance, this is force. Okay, dimensional formula of torque or moment of force, or you can say moment of force, its dimensional formula is, here we need to, distance is nothing but length, and dimensional formula of force. Okay, and dimensional formula of length is L, and that of force is mass into acceleration, mL t to the power minus 2, right? Mass, acceleration, this is meter per second square. Meter is the unit of length and second is square, second inverse square, meter per second square, so s to the power minus 2. So here we're gonna get t to the power minus 2. S is second, which is unit of time, right? So hope you have understood this. So this is gonna give us mL square t to the power minus 2. So this is the dimensional formula of moment of force, right? So hope you have understood this. Now let me take the next question. Now define moment of inertia. I have already defined this moment of inertia once earlier. Okay, this was asked in 2023. So definition of moment of inertia was asked in previous in 25 also, I think. I have already defined this one earlier in this video, right? So that's why I am not going to repeat this. So now what is the unit of this moment of inertia? We know that moment of inertia is now mass mi ri square. Okay, here ri is the distance, so mass is kg and ri square is meter square. So that's why SI unit, let me write it properly, SI unit of moment of inertia is nothing but kg meter square, right? Hope you have understood this. So if this represents the translational kinetic energy, translational kinetic energy is represented by this expression mv square, then this is the translational kinetic energy of a sphere. Okay, kinetic energy of a sphere. Then what will be the rotational kinetic energy if it rotates about an axis with an angle with an angular velocity omega? Now you see, this is the kinetic energy of a sphere. Okay, and we know that rotational kinetic energy, okay, rotational kinetic energy is equal to half I omega square. Okay, rotational kinetic energy is equal to half I omega square, and I is moment of inertia of the sphere, and we know that moment of inertia of the sphere, let me take a new slide, okay, to explain all these things. So here you see the translational kinetic energy, is half mv square of a sphere. Okay, we know that moment of inertia, rotational kinetic energy is given by this. Rotational kinetic energy is given by half I omega square, right? And moment of inertia of a sphere about an axis through its center, you must remember the moment of inertia of a sphere about its axis. Okay, so there must be a table in the chapter of system of particles in physics in your NCERT book. Okay, the moment of inertia of different objects, different geometrical of different body of different geometrical shapes are given. So you must remember those to solve such kind of problems. So moment of inertia of a sphere about its axis is axis through the center, that is given by 2 by 5 into mr square, where m is the mass of the sphere, okay, and r is the radius of the sphere. Okay, in that case, if you use this value here, then what you're gonna have? Therefore, rotational kinetic energy of the sphere, sorry, let me write it properly, of the sphere is half, instead of I, we're gonna put 2 5 mr square in then omega square. Okay, 2 cancels, so what we're gonna have? Half m. So this is the rotational kinetic energy of the sphere, right? Sorry, this is supposed to be 5. Okay, this is supposed to be 5, right? So hope you have understood this. So now let me take the next question. Okay, that's all, it's completed. Okay, so thank you for watching. See you in the next video. Bye bye.